So hopefully I got enough memory. So we're going to be doing this experiment. It's called red cabbage indicator. I'm not using red cabbage. Red cabbage is an indicator, but I'm not using that one. Today we're going to be using these strips, which tell me the pH for a wide variety of range. Also, I got a little bit of phenolphthalein solution in here. This will be, it's a little bit pink. It has water from the tap, so it seems to be a little bit basic, the water. Usually the water that comes from the tap has a pH between 6 and 9, and if it's a little bit basic, it's going to be slightly pink. It's not very an intense pink, so the water today seems to be a little bit on the basic side. I got cleaner here. This is simple green cleaner, and I got acetic acid, vinegar, and it's important in chemistry to know what is an acid and what is a base. There's a reaction that happens. We measure the concentration of hydrogen ions using a pH scale. So a natural substance can be used to determine the pH of an acid or a base. The pH scale uses numbers from 0 to 14 to indicate the level of acidity or basicity of a solution. A pH 7 is neutral. It is neither an acid nor a base. A pH above 7 is basic, while a pH lower than 7 is considered an acid. So acids tend to taste sour, like pineapple juice. I can give you an example also. Lemonade. Lemons are acidic. They have citric acid. Example of bases: dish soap, wide variety of cleaners. We're going to test some. I got a sample here. Sodium hydroxide. Sodium hydroxide. No, potassium hydroxide. It's 1 molar. It's a strong base. I'm scared of using this, but I'm going to do it for all of you so that you can learn. So we're going to be using the strips. I'm going to get some strips ready. So if you give me 1 moment, I'll put this phone over here. So don't go anywhere. I'm still here. Seems like it's a blackout, but it's not a blackout. I'm just opening this so I can access the pH strips before I use them. So, and again, we're going to be using pH strips. And the pH strips will tell me the pH based on the color change that is going to happen. Indicators, they change colors. These are the pH strips. So let me grab a few of them, separate them quickly. So I need 1, 2, 3. I'll take 4. Yeah. And these are test strips, so it's relatively easy to do this. So what you do is you have your little chart in here. I'm going to leave it there. So you have your chart with the color. So what you do is you take this and you dip in the solution. It will tell you whether it's an acid or base. The first one is going to be vinegar. So we're going to measure the pH. You should be able to see a color change. And right now we're getting an intense change color. I know the light doesn't help in there. It's very orangey. Right there, it's a good color. Like a witch. Let me see. Right there, yep, it's an orange color, very orange color. So when you go to a chart, you look at this, and the orange color tells me that this has a pH of about 2, I will say. Compare against the chart, yeah, it's about a 2. It's a 2. And again, this is vinegar, which is acetic acid. That is what you purchase in the supermarket. It comes in a bottle like this, and it's diluted to 5% acidity. So what we're going to do for this, we're going to write pH 2. That's going to be vinegar, and we're going to write what happened. Turn orange. So orange. So color change was orange. Orange. pH was 2. And this is vinegar. So now I'm going to take another strip. I'm going to put in the cleaner that I got. It's called simple green cleaner, and I'm going to check the pH. This one is turning relatively quickly into like a blue-green color. So this is a cleaner, and you can see the color. It's like a green. So I'm going to come here. So it tells me that it's going to be a very basic pH. So this is really green. So it's almost like towards the blue here. And this is going to be like a pH of, I would say it's about pH. It's almost like a pH 10. Yeah, looks like a pH 10. So This has a pH of 10. So I'm going to go here, pH of 10, and I had it here. So this is a pH of 10. And this is green, dark green, and this is going to be the simple green. I asked a custodian to give me a little bit of the cleaner that she was using, and that's why it has a pH of 10. Now I'm going to take a little bit of sodium hydroxide. And sodium hydroxide, I am scared of using that, so yeah. It's a very strong base, honestly. It's a very strong base. Like, it is really strong base. So I'm just going to add a few drops in here. And there was some phenolphthalein falling in there earlier, and you can see that it's turning this completely pink. That means that it's a base. Phenolphthalein in a basic solution, it turns pink. That's the color change in there. So some phenolphthalein fell in there. I got the pH strip in here, and let's see what color it turns out to be. This one is turning quickly. You can see that it's turning blue, very dark blue. Oh my gosh. Yep, I told you this is a strong base. So this is like a 13, pH 13 right there. That's a strong base in there. Oh my gosh. Yeah, this is a very strong solution. Yeah, it's a strong base. pH 13. This is a strong caustic zinc. This also used called potash, potassium hydroxide. It's also used to make soap. If you watch the movie Fight Club, there's a scene that in there where chemical burn happened. Don't even get that. I'm afraid of using this. I'm wearing gloves. You can see that I'm using protective equipment because this is not something that I want to touch myself, because it's really caustic. So yeah. And the only thing to get rid of this is to neutralize it. How you neutralize it? You add an acid. So I'll probably have to do that, so that way I don't release that into the sink. Anyway, so this one, pH 13, 13, dark blue, potassium hydroxide, and yeah, it's a solution that is 1 molar. 1 molar means that there's if I will to make a solution of 1 liter of solution, it will have 1 mole of potassium hydroxide in there, dissolved in water. So let me do the answers quickly for you guys in the back. So we're going to the back. So what is the pH range of an acidic solution? So an acidic solution, the pH will be 0 to 7. It will be less than 7. 0 to less than 7. What is the pH range of a basic solution? A basic solution will have a pH greater than 7. So according to Arrhenius, what ion does an acid yield when dissolved in solution? So an arenous acid is an acid that yields a hydrogen ion. In solution, sometimes we express the hydrogen ion as H3O plus. Again, this is different from water. So ionization of HCl in water. So if we ionize HCl, it's a strong acid, it will completely ionize in water. So this will be H plus Cl minus. This will be aqueous solution. It will completely dissociate. A strong acid will always dissociate. According to Arrhenius, what ion does a base yield? A base, when it's dissolved, will always yield hydroxide ion. That's OH negative. There's a hydroxide ion. It's a polyatomic ion. polyatomic ion because it has more than one element in there. So sodium hydroxide is a strong base. It's similar to potassium hydroxide. So NaOH completely dissociated in water to sodium ions and hydroxide ions. So this is the answer for this. The pH of the unknown solution, don't worry about this. We didn't have an unknown solution. All of them were kind of unknown. Unknown solution, acid or base, don't worry about that. We don't need that. Now, what you learn about pH of acid and bases? You know, we'll talk about it in terms of the pH. And if you need more guidance, you can look online. But there's enough information for you to be able to write 1 to 4 sentences describing what you observed and what you learn about acid and bases. And again, the key here is like an acid produces hydrogen ions in water, a base produces hydroxyl ions in water, and that the pH range of an acidic solution is less than 7, and the pH range of a base is greater than 7, and the pH 7 is neutral. Any questions? Come and see me and ask the questions. Have a great day, and I hope you had enjoyed this amazing experiment. Bye.